Hello, my name is Stefan Höttling, and I would like to welcome you to my presentation, Virtual Commissioning of a Warehouse Control System, including the creation of business graphs using the Simplan reporting tool SimAssist. First, I would quickly like to introduce Simplan to you. After that, short project description, why I think you should emulate 3D, project steps, how the emulation environment looked like. After that, short live demo, and then a summary about the learnings during the test phase. After that, I will hand over to my colleague Tobias, who will tell you more about reporting we also implemented using our SimAssist tool. So Simplan was founded around 30 years ago. We're mainly based in Germany. Our head office is close to Frankfurt in Hanau. We meanwhile have 9 offices in Germany. Myself, I'm located in Munich and working since 15 years for Simplan, mainly in sales for projects and also for Emulate 3D. So we're around 80 simulation and emulation experts. Our main business is doing projects, so services, which is around 70% of our business. I also like to say we act as an enabler, so we make it easier for our customers to do simulation and emulation. So this is the creation of components and libraries, automatisms or complete simulation solutions. And we are also, since the beginning of Emulate 3D, value-added reseller in Europe. So we resell the software, we deliver trainings, first-level support. So our idea is that we can deliver everything out of one hand as soon as it's about simulation and virtual commissioning. So who are our customers? So these are the big system integrators, companies that do the design of MHS systems, automation companies, machine builders, transportation companies, so across industries, also a good part in automotive industry. So let's move over to the project I would like to talk about. So the project was about the exchange of a proprietary material flow controller to SAP EWM MFS. So a typical brownfield project, a running system. Some of you might already have heard about SAP Extended Warehouse Management. We see the software more and more in Germany. Many companies do already have SAP, so they also tend to use SAP product for the material flow controller. And we see many companies transferring their systems from proprietary systems to EWM. As it is a standard, there are different system integrators out there in Germany, so they can also change their supplier if they are not happy with the former one. So the conversion should happen over the weekend. So stop Friday 6 o'clock and start Monday 6 o'clock. So quite a risky project, as you do not want to interrupt the production for a longer time. Involved parties, sure, end customer, then the SAP system integrators, and us. The system was a 9 AL pallet warehouse, cranes with load handling devices for 2 pallets, roller chain conveyors, turntable transfers, partial manual forklift truck transportation. I would call it a typical pallet warehouse. So because of exchange during runtime. It was decided to make a high-level emulation, to have a test bed for the SAP EWM implementation. And the main question was, will the plant again Monday 6 o'clock, or will there be any issues? So this was the main question. I also wanted to quickly tell you about a project that was short of budget. So we needed to save some money. So we took out some conveyors to achieve that. Sure, at the same time, we needed to make sure that it works, the system. And there we go. Sure, we also simulated that like you see here. And yeah, we also needed to make sure that operators can walk there. And let's see how that goes. Ooh, and we were lucky enough that we can do it like this. So let's get back to serious. Why we think you should emulate. We think a big point is that you can test independently from the real system, from the real mechanics, automation equipment. Do this in the office. Regarding high-level emulation, you usually have different testing phases. First, you test the interface to the SAP system, then you test, so that's just basically a telegram test without the emulation model in the background, and you test the single transport, so from point A to B, then you do mass tests where you have all the flows, and you also have the possibility to test errors, which is very hard to do in reality, because how to trigger an error. And even when it's a test run, it's very easily done in the virtual world. So trigger a weight failure, bin full failure, or a profile failure, and then you want to see how the material flow controller reacts to these kind of errors, if they are handled correctly, or if the logic is not implemented well. It saves you a lot of money, as you do not need to have any physical operation. So you don't need any forklift truck drivers, any pallets or production somehow. It's all virtually. It's easy to reset and therefore allows you to do much more test scenarios than you will be able to do on site. And this will definitely lead to better software quality at the start of the commissioning on site. Plants are built around the world, as you know. So the virtual commissioning will save you a lot of travel costs. Also, at the same time, reduce the workload on your employees. Keep them in the office as long as possible. Save their energy. I think that's getting more and more important. And yeah, even during Corona time, it still isn't possible to go on site. So you need to do as much virtually as possible. And overall, it ensures that the system will be up and running when it was planned to be up and running. Prevent contractual penalties. So I think also a very valid point. What we also see is that the test environments are used additionally for operator training. Furthermore, many companies meanwhile use the test environment from the commissioning phase as a real digital twin. So run it in parallel to their operation, use it for the release management. There will always be improvement in the material flow controller. And they do automated test scenarios to make sure when they had changes in the material flow controller, they didn't break anything. So what project steps did we have? It's always a good idea to write a specification. It's based on the SAP blueprint, layout, control point layout, interface specification. Still, it's a good idea to do a workshop, at least virtually, with your customer and the SAP system integrator team to talk about the projects, the flows, etc. After that, we created the Emulate 3D model. We needed to define all telegrams which we plan to run in the system in our emulation controller. After that, we tested the model and also our communication module internally using one of our tools, which is called Simtel, which can control systems rule-based. So it's basically a simplified material flow controller. So we try to find our bugs ourselves to avoid any annoyance on customer side. After that, we actually did the first test runs, emulation runs together with the SAP team. So basically commissioned the whole test environment, trained them, and handed over the test environment. And after that, it was up to them to do all the test scenarios. They only basically called us when they saw any issues they couldn't explain themselves. But apart from that, it was up to them. So you might be familiar with the typical topology of an MHS system. So SAP as a host system. Then you have the EWM, a material flow controller, PLC, sensors, drives on the left side. And for high-level emulation, you make a cut underneath the material flow controller. Then we have our Simplan emulation controller, which is an interface module. I will introduce in a minute. You see a screenshot of it, and underneath it we have our virtual model in Emulate 3D with all the mechanics, sensors, drives, and also PLC strategies. So a couple of slides about our emulation controller. So it's an interface module which sits in between SAP and the emulation model. So it receives all the telegrams from SAP, usually over the TCP/IP. So it's a counterpart of the EWM system. It receives the telegrams, filters out the relevant information for the emulation, does acknowledgement, for example, and forwards the information to the emulation model like a drive order for a pallet. And when it receives feedback from the emulation model, it also assembles telegrams and sends them back as an answer to the material flow controller, for example, to notify EWM that a pallet arrived at a certain station. It also takes care about sequence numbers, for example, heartbeat, live telegrams, debugging, tracing functionality. When you see errors in that during emulation to see was it a telegram error, in general to see what's going on in the system. During an emulation project like this, you need to define all telegrams that are used in the system, because for SAP, it's no different if it talks to the emulation controller or to the real PLCs. So in our emulation controller, we can do that graphically. So it's a little bit like in quick script. So for every single telegram, you need to define header information, length of header, content, footer. So that's very, very efficiently to do in our emulation controller environment. We have also enhancement in Emulate 3D itself. So we developed an add-in where you connect to the emulation controller, reset starter model, set the run speed. Our experience with high-level emulation is that you can accelerate the simulation speed up to 20 times real time. So we can test much faster than real time, which is pretty much appreciated because you want to test an overall system. We also created related components in Emulate 3D for conveyor stations. When you have created a model, our emulation controller reads all these components automatically from the scene and also offers them in the emulation controller. So it's a closed workflow for us. It's pretty much standardized. So let's have a look at the test environment. Here our warehouse with the 9 aisles, conveyors, roller conveyors, chain conveyors, transfers, turntables, and you see we have all the stations, same naming sure than in reality. So these are our communication points with the SAP system. And on top here we have our add-in emulation controller add-in to connect with the emulation controller, reset, start the model, run speed during testing, and this closely interacts with our emulation controller software, which you see here. So on the left side, you see all the connections to the PLCs. So we have 10 PLCs in the system. SAP talks to already connected to them. Here you see our location manager. So we have an overview of all stations in the system, naming, status. We can zoom to them. We can toggle failures. So basically have access to all the stations in our model. In our transporter overview, you see the status of our single components, cranes, shuttles, and the next thing is to have a look at our location manager, where we can manually, but also based on a spreadsheet, create loads. So here is our load overview. We create a new load, select the transport type, select a station where we want to place the pallet, create it. It appears here. We will create a couple of more pallets. So we have more movement later on in the system. We also need to call the forklift truck. So when we create the load, we generate a transport order. A telegram is sent to the SAP system to notify the system about it. And then it's up to the material flow controller to set the target, control the flow. And by that, we can test so the communication work correctly. Is the routing correct? Here you see all the tracing we have. We see the communication, all the telegrams, to understand when something goes wrong, where it did go wrong. What you see next is our so-called Simtel, which is basically the material flow controller. So it's a route-based routing. So we use that to commission the model before we connect it to the SAP. But for now, see it as the SAP system. So it generates telegrams, sends it to the model, receives answers. You see here a protocol of all the telegrams received and sent. Here you see what the telegram looked like, and on the right side you see the contents of the telegrams. Also, to understand when something went wrong, what the problem was. So again, here basically our material flow controller, which sends and receives telegrams to and from our emulation controller, and the emulation controller connected to the virtual model, and that's basically the complete test environment. So how did the project go? So first of all, it turned out that the blueprint was partly wrong and not complete at some point. So that was a good thing right at the beginning of the project. So it helped to avoid wrong implementations in the SAP system, just by, reading all the documents and talking to the project team. Then during the mass testing, it was found out that the randomizer for the yield target selection didn't work very well, which led to an unbalanced load distribution in the warehouse. This is something which you do not want to have, because you want your SKU spread overall the warehouse. So that needed corrections in the SAP system. And it also was found out that at some points SAP assigned wrong target bin height classes. So the bin was not high enough for the pallet. And you can imagine that in reality, this is a very bad situation when you try to put a pallet that is too high for a certain bin into it. So this can become very messy. So this was very important for the SAP team to find that bug before they went on site. So the system was fully commissioned after 2 weekends. So this was exactly how it was planned. So the virtual commissioning went over around 4 weeks. Sure, not full-time testing, but that was basically the testing period. So it's hard to say how much time was saved on site. We usually do around 20 high-level emulation projects a year, and our experience and experience of our customers using the technology is they all say at least that 50% of the time on site is reduced. Some even say commissioning on site is no longer necessary. So that's the bandwidth we hear. How did robustness of the software improve? Also hard to measure. How does the overall equipment efficiency in the end improve? Our guess is significantly, but like I said, it's usually hard to measure. So it was a successful, a very successful project. So the end customer was happy that he didn't have any longer product interruptions. The SAP team was happy, to do the findings and not to have the issues on site. And it turned out that technology worked very well and also very robust. The SAP during the mass testing phase also wanted to compare different material flow strategies. So we also implemented reporting for throughputs at some points using our Simsys tools. But Tobias, I will hand over for Tobias, who will tell you more about what we did there and how it looked like. So thank you very much for your attention. I will be available for questions later on, and I hope to see you personally again during the user group meeting next year. Thank you very much.
Thank you, Stefan. Hello, everyone. I would like to show you Simsys, our simulation support tool, and how we use it in our projects. Let me start with showing you the simulation process, how it usually works. We have a system design, we build a simulation, We run experiments with that, we evaluate the results and present our findings. Sometimes the simulation project is already over at this point, but more often than that, we have to define more experiments, run experiments again, evaluate results, present our findings. We sometimes have to update specification, build the model, update the model, run experiments, evaluate results, present our findings. Sometimes we have to improve the system design together with our customer, then build the simulation or update it again, run experiments, evaluate results, present our findings. As you noticed, I went through this part a lot. So we also noticed that, and we decided we want to support ourselves by doing this, and therefore we created Synesist. When we had a closer look at these aspects, we found that when you run the experiments, you have to configure and start the experiments. You have to collect and accumulate the data. We evaluate the results, and therefore we need to create charts, aggregate data tables, and those and we analyze and draw conclusions from that. It's not where it stops. We still have to create a presentation from this and present and explain the results to our customer. Now, if you look at these tasks, the two of them here, they are fairly difficult and need a lot of knowledge, need a lot of thinking. The other four are more repetitive and therefore are ideal candidates for automation. And that's what we did with Synesist. This is an overview of what Synesist does for us. We have a database connection, we have some tables to view data, we have several components to quickly check data and aggregate data, we have many options to visualize data, we have some advanced visualization components that do categorization or distribution fitting, we have several documentation plugins, and we have a module that calculates some process data for our cranes or our monorails, so we don't even have to simulate sometimes, but can immediately say that what the performance of these components would be. I would like to focus on three components for this presentation. It is the database definition. We always need data to work with. We have a SimChart component to visualize data, and we have the PowerPoint plugin to export our visualizations into the PowerPoint presentation. Now, to work with Synesist, we need data. The data is created and generated by Emulate3D. We store the data in an SQLite database and then use that in Synesist. The model is the model that Steffen already showed you. We will just look at this little loop segment. We have some fill level and throughput counters for that. And this is what Synesist then looks like. Now let me go into a live presentation and show you the actual program. Here we have Synesist. So we have the database definition, as I said earlier. Here we can insert different sources, the path, etc., and then we have the tables that are in the database. We use those to create charts like this. These are, in this case, kind of similar to pivot charts in Excel. We can draw columns over here to see what we want to show. For example, I can remove the min and max and only show the average, add the max, the min. And I can also filter my data if I like to. For example, here I have one interval that doesn't really contain important data, so I filter it out. There's no need to talk about that. And then I have the third component, the PowerPoint plugin, and exports our charts into a PowerPoint presentation. I want to show you this here. So here's our presentation that we're just looking at. When I now go into a Synesist, have the presentation selected and click export, these charts are exported into the PowerPoint presentation. I'll show you a larger scale. Here we have our charts that we've just seen in Synesist. Now if I want to aggregate those a bit, I can also just take the ones that match. This is for the throughput histogram. I will add that to the interval data, and I will do the same for the fill level. I will again add the histogram to the interval data. So I have both available at the same time. These, and now you see these diagrams are a bit skewed. I can just export again, and then they're nicely readable again. So far, this is very similar to a procedure you could also do with other projects. But what I think is very important now is when I run the experiment again, maybe with some other parameters, I just go into SimAssist, update the path to the database, and then I update my project. Let me show you here. So here this is the old data. Now when I update the project, it shows me the new data, and then I can just update my presentation again and have the new data in the presentation. So it's basically changing a path, click of a button, and I have the new data in the presentation. Now I can focus on analyzing the data and drawing conclusions from that. This is already it. Let me go back to the presentation. I want to sum up what we did. We have our simulation process. We have this aspect that we do a lot because it's an iterative process. We run experiments, evaluate results, and present the findings. We use SimAssist to create a presentation only once and update the presentation with new data, and then we can focus our energy on interpretation and drawing conclusions and on presenting and explaining to the customer. I hope you took something away from this presentation. If you have any more questions, feel free to get in touch. Thank you very much for your attention.